Okay, so this is specifically for just a request of how we can simplify. Again, I'll say it one more time. The way you do it versus the way I do it might be a little different, but this is just another way of solving a puzzle. So there's more than one route you can take. Starting with the left side, because this is not algebra, you're not supposed to like multiply left and right. But anyways, put that aside. I am going to deal with a positive exponent first, simply because, well, I don't want to have to worry about a negative exponent. So the denominator is a numerator. The numerator is now 2 to the power of, yeah, yeah, so this is half, and 3 over 6 is also half. So you can actually say that this is x to the power of half times x to the power of half. That's actually a 1. So I think you got it. Sometimes that's all it takes. Just asking out loud and processing it out loud. And from here, the exponent applies to everything. So 5 times 5 times 5 times 5, 525, 125, 625, x to the power of 1 over 2222 is 248, 16, x to the power of 4. So if I simplify that, this becomes that. That's it. And on the right side, you can simplify and see if it adds to the same thing. Okay. All right. Welcome, everyone. This is essentially our last time together before half of you have a test on Monday. So we're going to continue reviewing. There's nothing new. I hope you had a little bit of a breather that last class when we were looking at exponential functions and learning some word questions was a bit of a break where we were just matching numbers together. But today I thought we can try some questions from our chapter review, namely chapter 1, number 2, and chapter 2, number 3 are good ones that cover a large, I guess, a variety or a large section of what we are doing. Chapter 1, number 2 uh, is, given a parabola or given a function, give me the equation and do some other stuff and talks about domain and range, which I think covers a large chunk of chapter 1, the concepts in it. And then chapter 2, number 3 is about inverse and transformations. So that will cover a large chunk of chapter 2. So I think it's worthwhile to look at questions like that. From there, you might have also noticed that um, I have been posting videos to of answers to the questions that have been sent in by request by some of your classmates. Please use it to your advantage, and if you have your own that you'd like to cover, then yeah, don't hesitate to send an email my way. I will do my best um, to respond in time. Okay, let's see, take a look in at chat. Will we have time? Does it matter if, okay, Saima, I will answer that as I said, using number 3. Okay, have your spacebar handy. I'm going to quickly do attendance. In my F1 class. Claire,
Here.
Clara, uh, Kiara, 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 are you here? Oh, okay. Let's move on. Zane B,
Here.
Clara,
Here.
awesome. Ian,
Here.
well, you're right there. Carson,
Here.
great. Noah,
Here.
Lucas,
Here.
Emily,
Here.
Louisa,
Here.
Jonah,
Here.
Nathan,
Here.
Harriet,
Here.
great. Saving, and F2. Monad, he did email me earlier. Did you make it? Okay, hopefully you're back soon. Charlotte,
Here.
Amina,
Here.
Josh,
Here.
Saima,
Here.
Waylon,
Here.
Connor, Patrick,
Here.
Murdoch,
Here.
Kinda, Kinda, no? Oh, it's rare. Oh, I think I might have gotten an email from her. Okay, Gemma,
Here.
Helen,
Here.
Aiden, Aiden, when I see you online, Aiden, are you with us?
Were you calling on me? Sorry.
Yes. I got you
Okay,
then.
yeah. Yeah, I'm here.
No, Noam,
Here.
Zane T,
Here.
and Zoe.
Here.
Excellent. Okay. Everyone is accounted for from the people who sent an email. Okay, let's try this. So going back to my whiteboard, we're going to try chapter 1, number 2, chapter 2, number 3. If you have any other questions, please let me know. If you want me to try something because you're like, I don't remember how to do that, and you wanted a quick refresher of some of the topics from our chapter review, I can give that to you as well. Otherwise, that's it. It's just extra study, so I'm not going to force you to do questions that I think you should do. Just do the ones that you found challenging and just brush up on that. Okay? Chapter 1, number 2. So we have a parabola, point are 4, -8, 6, -6. So chapter 1, number 2, they give you a parabola. I have no idea where the parabola is relative to the x-axis, but I do know this is 4, -8, and I have a random point 6, -6. Okay, the question asks you to find an equation, solve roots, so x-intercepts, and then give me domain and range. Okay, so if you, oh, what was that? That was weird. Give me a sec. Okay, that should be good. I think my foot was playing with the outlet. That was scary. Um, so if you go back to our section or our lesson on finding equations, given the graph, you might remember that we need specific points. We need either the question to give you a vertex or the actual x-intercepts to be able to successfully find an equation. You need something special. Now, of course, there are ways to do it without the special points, but that requires, substitution, elimination, stuff that we haven't covered this year. It's not that it's impossible, it's just a bit more difficult. This question gives you the vertex. If this was a test, I hope that you will come to the conclusion that you need to use vertex form to make use of the vertex. If I give you the x-intercepts, you'd want to use the x-intercept form to make use of the x-intercepts. So let's do it. X. The vertex is a 4, the k value, and -8. So 4, -8. This is as far as we can go, and it'll be nice to have the a value. To find the a value, all of my other variables like x and y need to be filled. So let's do it. When the y value is -6, I know that my x value have to be 6. And if I simplify and do some quick algebra, I'll be able to find a. Plus 8, plus 8, that is 2. And 6 minus 4 is 2. 2 is equal to a times 4. So a is equal to 2 over 4, or 1/2. My final equation is a x minus h plus k. I hope you remember that. It's just slowly coming back. All these little things were techniques and tricks and lessons that we learned in grade 10. And so chapter 1 is essentially a grade 10 crash course.
If we were to put y equals half x minus 4 squared minus 8 instead of f of x, would we get half marks or would you still get the full mark?
Say 1 second. I need to go and fix attendance for a second. What was that? What was the question?
Just if we put y equals instead of f of x equals, would we get half marks or full marks?
No, y is fine, but I will say either one is okay. The only time you would want to put f of x is if there's more than one function you're dealing with. So you have to identify between this y versus that y.
Okay, thank you.
So, just in case, you know what? You're heading towards grade 12 anyways. Just in case, get into the habit of using f of x. Function notation becomes important. Yeah, I'll say that. Use f of x. Do your best. The only time you actually need to bring it, write it as a y is when you're doing the inverse function, and you'll see in just a second. All right. From here, the question says, hey, find the roots for me. In other words, tell me where it crosses the x-axis. What would you do? I have an equation, it's in vertex form, and I want to find the x-intercept. What do you suggest? Anyone? Going once?
Could you repeat it?
Pardon?
Could you repeat it for a sec?
Oh no, the question is, what would you do to find the x-intercepts? You have the vertex form, and what you're looking for are the x-zeros.
So you make y equals 0.
Oh yeah, that's an easy way. Um, so if you were thinking maybe we can like multiply this out and then look for the factored form, right? You could do that, but that is a bit of a long roundabout way. What you might notice is the x-intercepts all have a y value of 0. So take the f of x, right, and say, okay, this equation has to equal a 0. What values of x make my y value of 0? And again, let's do some algebra. Plus 8, plus 8. 8 is equal to x minus 4 squared. Again, in case you were wondering what the heck is going on, I am trying to isolate this term because it has the x in it. So I got rid of the negative 8. Next, let's go further. I am trying to isolate this portion, this bracket, because it has the x. So how do you get rid of the half? We're going to multiply both sides by 2. Oops. Nice. Now that I got everything separated from the bracket, my next goal is to get this inside all alone. Again, I'm trying to unpackage everything to get x all alone. So how to get rid of a square? Square root both sides. And when I square root both sides, the 16 becomes a plus or a minus 4. So now I have two answers. If this happens to be a plus 4, and I have to add 4 to both sides, x could be an 8. If this left side happens to be a minus 4, and I add both sides by 4, it becomes a 0. So let me write this again. If this was a plus 4, and I add 4 to both sides, x becomes 8. If this happens to be a minus 4, and I add 4 to both sides, x becomes a 0. What does that mean? When x is 0, y is 0, or when x is 8, y is 0. This point is 8, 0. That point is 0, 0. Any questions about what's happening there or how I got through? I'm really hoping that although it's been a little bit, there's been a bit of time, sometimes looking at something with a fresh set of eyes really helps to understand. It's like, oh, that's all it was? And sometimes you just feel a lot better about it when you look at it again. The final section of this question asks for domain and range. And I'm just going to do it myself. Just give yourself 30 seconds to think what would be the domain of a parabola, what would be the range of a parabola. Okay. For a parabola, because it continues forever without any limitations, x belongs to any real number, and that's it. For the range, however, notice how the parabola continues to go upwards and will never come back down. Y belongs to any real number, but y has to be less than or equal to a -8, because it tells me right there that it's a -8. It's all coming together. Any questions? No? Let's talk really quickly about certain spin-offs of this question that you might see on a test. And you could put a little note about it next to your copying if you want, right? Instead of a vertex, I could give you the roots instead, like this. And I actually give you these points, and then I ask you for the equation, which means instead of vertex form, you might want to start with this. Oh, here's another one. After getting you to write the equation, I might ask you, hey, what are the transformations? Like, what if once you calculated this function, right, the vertex form also happens to be the same form that uses AKDC, right? AKDC. What are the transformations from the parent function of x squared? That gives me this. And you'd have to give me, the vertical compression by a factor of 1/2, shift to the right by 4, shift down by 8. What else did I say in my summary? What else could I have asked you for? Chapter 1. Oh, linear quadratic, right? What if I ask you to find the equation and then I say, hey, there happens to be a straight line that crosses it with an equation of y equals, x minus 7, right? Where are the 2 points where it locates? Then maybe you'd have to take that and make it equal to that equation. See how I can sort of weave a whole bunch of topics together? Try to look at the different topics and identify how they might be connected to each other. And that is one way you can, play some Jedi mind tricks and get into my head. Try to predict the kinds of questions that I could ask you, because I am limited to 45 minutes. I have to check if you can cover or you can understand or you can solve certain key topics in each chapter within 45 minutes without making it impossible. So I can't ask you like the highest tier difficulty questions from each section. That wouldn't be fair. Right? I can't ask you the achievement check for 1.1, 1.2, 1.3, 1.4. It'll be long, it'll be difficult. I have to be fair about it. So if I didn't tell you already, the caliber of the questions are not going to be like the problem set I give you. The caliber of the questions are going to be, the multiple choice would be relatively easy, and the written short answer question will be probably medium difficulty, where you still have to think about it. It's not just you be a machine. You just got to think a little bit about it. as a teacher, I am limited. There's very little that I can do to make it challenging but still fair. I gotta balance the two. Any other questions? Okay. Try to get in my head and try to predict what I might ask you. My next one is going to be chapter 2, number 3. And that involves inverse functions. Oh my gosh. There it is. Let me see if I can write it down. I think I made a video of this because someone asked about it, but I'll just do it together with you anyways. F of x minus 2 squared minus 1. Okay, so this question is going to answer a question that was asked in chat, and that is about the k value. Is it important to always factor it? The answer is yes. Okay. The question in the sheet says, state the transformations in correct order, sketch the parent function and the transformed function, give me domain and range, and then do the inverse and compare AKDC. There's a video of that I've already done, but let's work it through. Right now, you might identify, let's do it different colors, A, and then K, and then B, and then let's use orange, C, in that manner. But you have to be careful because what I'm going to say, the general equation for transformation is in the form of A multiplied by the function K is multiplying to a binomial that involves x and the horizontal shift. If you take a look at this and compare, you will notice that the k value is directly multiplying with the x before the horizontal shift is applied in that sense, right? You need to for a factor as best as you can. You must factor before you do anything. Otherwise, you might think that it's a horizontal shift 2 to the right, but in reality, it's a horizontal shift 6 to the right. So these transformations this is how you would write it properly, word for word. I'll tell you what I'm looking for. If I ask you for the transformation in words, you would have to say that this is a vertical compression because I am smushing it, I am making it small, I'm flattening it out, I'm multiplying everything by 0.5. So by multiplying, you have to say it's a factor of half. If you just say vertical compression by half, it's not technically not correct, or there's room for error when you read that and interpret it. Please use the word factor of. Next, there is a horizontal stretch by a factor of 3. Please notice that the k value is 1 over 3, which means you multiply all the x values by 1 over k. If you haven't caught on already, there is that point, that part when we were learning about mapping and transformations that I showed you how the x value is multiplied by 1 over k, right? That's how it changes. If I put AKDC all together, remember, I'm not sure if I shared this with this class, but I do know that I gave you parts of it. The x is multiplied by 1 over k, and then it is shifted to the left or right. The y is multiplied by the vertical factor, and then shifted up or down. Okay, let's continue on finishing the transformations. As I said, is a horizontal shift 6 to the right and vertical shift 1 down. Questions? Okay. Next part. As practice, depends on how much practice you actually need. If you want accurate drawings, then you can use a sticky that I gave you. Otherwise, remember, if this is just practice, get comfortable doing a sketch and being confident that you know exactly what you're going to do if I ask you for a good copy or a neat copy. This is my x squared. Vertical compression by half. Let me do that in red. So everything is going to be halved. So my parabola is going to look like this. This is half x squared. And then I will use blue because I did that. The k value, I am multiplying everything by a factor of 3. So that means I am horizontally stretching. That's a point. That's a point. That's a point. And that's a point. So it's going to look something like this. A very wide stretch half. 1 over 3 x squared. From there, move to the right by 1 and move down by 1. I'm just going to jump it because I think I can count the dots carefully. 1, 2, 3, 4, 5, 6, and 1 down. Here's my vertex. This point goes 1, 2, 3, 4, 5, 6, and 1 down. 1, 2, 3, 4, 5, 6, and 1 down, somewhere here. And this is somewhere like that. Remember, this is just a sketch, so it could be a little bit off, but I want to show you that this is approximately where the final graph would be. Okay. Whew. That's a lot. Take a look. So this is the factoring. This is the transformations. This is actually working at doing a graph. And now I could link this and ask you to calculate the inverse function. Let's do this. So if I want to calculate the inverse, I'm going to bring the f of x and turn it back into y. I'm going to, just like the graph, swap the location of x and y because I am swapping the independent and dependent variables. It's the exact same stuff. Now, I could leave it like this, but by convention, we want the equation to always equal y isolated. And so, I'm going to work that out. First, I want the term that has the y value to be isolated. So let's get rid of the negative 1. Plus 1, this is x plus 1 equals half 1 over 3 y minus 6 squared. Next, now that that's done, I want the section or the bracket that has the y value to be isolated. So let's get rid of the half by multiplying both sides by 2. X plus 1 is multiplied by 2, leaving me 1 over 3 y minus 6 squared. I have to get rid of the square. Let's keep going. 2 x plus 1 equals 1 over 3 y minus 6 in brackets. Will I have space for this? I hope so. Now, oh, I forgot to highlight. So I want this part all alone. Now I want this part all alone. I want to multiply both sides by a 3. So 3 square root 2 x plus 1 equals y minus 6. And now, after all that, I can finally get the y all alone by adding 6. Whew. While you are working that out and just copying, I want to say that some of you might ask, hey, I know you use this equation on the left, But what if you use the original equation? Would you get the same answer? And the answer is yes. The only issue is you might run into some trouble while trying to isolate the x by removing the 2. You will see that if this is not bracketed the way I have here, you actually have to remove the 2 before you remove the 1 over 3, which isn't impossible. It's not that it's hard at all, but you might get tripped up because you might forget to do something when you multiply the 3. You don't have to bother with that if you're not interested. I just want to warn you, or just want to let you know, that it is the exact same equation. Are we done this question yet? It asks you to state the domain and range, which I think you're able to do for the parabola. And then it asks you to compare the inverse function's AKDC with the original AKDC. I think this is pretty interesting. Let me clear some space just to give you an idea of what I mean by interesting. Please recall, the inverse function is essentially a reflection of the y equals x line. Take a look at this. Ready? The inverse function has a vertical stretch of 3. In other words, it is a vertical stretch of 3. But if this was flipped using the y equals x line, that would have been previously a horizontal stretch of 3. Do I have a horizontal stretch of 3? Damn right I do. Horizontal stretch of 3. Let's do it again. The inverse function has a horizontal compression of 1.5. Right? So k value of 2 means I have a horizontal compression of 2. I'm pushing it towards the y-axis. So if that is a horizontal compression, if I flip it, the original equation would have been pushing up and down. It would have been a vertical compression. Do we have that? Damn right I do. Same thing. This question has a shift to the left. So I am moving to the left. If this was mirrored on the y equals x line, that means the original must have been shifting down. Do we have that? Damn right I do. And lastly, this one has a shift up of 6. If I flip this on the y equals x line, then I should have a horizontal shift to the right by 6. Do I have that? I think you get that. So it works. What you're doing makes sense. You're doing it correctly. And, inverse function, it still applies to AKDC. It follows the same mapping theory. Oof, that was a long one. Worth at least 5 marks on the test. Any questions that you'd like to cover? Because frankly speaking, if there are no other questions, all that's left is for you to use the weekend to organize your notes, figure out what you could use some more practice on, and also work on your study sheet or your cheat sheet. Okay. All right, I'm going to open up the floor. Are there any questions, even from the textbook, any questions you would like to do? Because I will be happy to take it up in hopes that it will help other people in the class study better. Any questions? Yes, I'm not gonna limit. I mean, I'm already giving you a cheat sheet that's like not supposed to be in a normal year, anyways. So I'm not gonna just limit that. Just use whatever that piece of paper will offer you. But you might want to practice making the cheat sheet in an organized and neat way. If you ever decide to go to life science or engineering or even computer programming and coding, they may allow you to have a cheat sheet. And the smaller you write and the more organized you write, the faster you'll be able to navigate through. So for the future, your future self will thank you. Try to write organized, categorized, and make it neat. I see the thumbs up. Any other questions? None? Okay. Well, let's stop the video here for a sec.